The alcohol functional group is characterized by a hydroxyl group that is substituted for one of the hydrogens on the original hydrocarbon. A hydroxyl group is an OH, oxygen single bonded to another hydrogen. Now, we've seen this grouping of elements before when we talked about Arrhenius bases, but it's important to note that alcohols are neither acidic nor basic. So you have the same configuration of atoms, but different behavior in this case. With your smaller alcohol molecules, ones that generally have 4 carbons or less, these alcohols tend to be water soluble. Get any heavier than that and you start to get less and less solubility. In order to name a hydrocarbon that contains an alcohol functional group, you need to look for the longest continuous chain of carbons where the OH is directly connected to it. Okay? So when we talked about alkenes and alkynes, it was the longest continuous chain that contained the double bond or the triple bond. Now we need to look for the longest continuous carbon chain that has the hydroxyl group directly attached to it. Whether it's at the end of the chain or in the middle of the chain, it must be directly attached to the parent chain itself. Your position number for the hydroxyl group precedes the stem name. So right before you identify how many carbons are in the parent chain, you would put a position number. And the ending that comes after the stem changes to OL. So if you had an alcohol group on an alkane, instead of ending in ANE, now the name is going to end in ANOL. The E is swapped out for the OL ending. So anytime you see OL on the end of a name, you know that it contains an alcohol group. Some common alcohols with which you should be familiar with. Methanol is a 1-carbon alkane with a hydroxyl group on it. Methanol is also referred to as wood alcohol sometimes, and it's found in windshield washer fluid. Methanol, if ingested, can be extremely toxic and cause blindness, even death. The kind of alcohol that is able to be metabolized by the human body is ethanol. It contains 2 carbons with a hydroxyl group attached to that parent chain. This is known as grain alcohol, and this is the type that you find in beverages. It's also the kind of alcohol that is added to gasoline to make burning. Ethylene glycol is a diol, as they're referred to, because it has 2 hydroxyl groups. Ethylene glycol is, again, a very toxic form of alcohol, but it does have a sweet taste to it. And this is the primary ingredient in automobile antifreeze. And this is why if you're walking your dog and you see a puddle of bright fluorescent green liquid and they go over and they start to eat it, you want to get them away from it as quickly as possible. Don't even let them near it in the first place. They're attracted to it because it is sweet tasting, but the primary ingredient in the antifreeze is this ethylene glycol, and it can be very toxic, make them very sick, or even kill them. The last alcohol that you see here is a triol because of the 3 hydroxyl groups, and that's known as glycerol. It is a non-toxic triol that is also sweet tasting. And so you get glycerol being added to food products in order to keep them soft and moist over extended periods of time. So if we use our skills in naming, if we look at the first example here, we have a 4-carbon alkane, which would make it a butane, and a hydroxyl group coming off of carbon 2. So this would be referred to as 2-butanol. Notice how the E at the end of butane is swapped out for the OL ending, indicating that it's an alcohol. If you take a moment and look at the next example, the second example, try that on your own, and then restart the presentation. Alright, with this one, you have, again, this one is a 5-carbon alkane, so it's based on the pentane structure, and your hydroxyl is at the end of that chain. So we would number the pentane chain starting with the end where the hydroxyl is attached. That would take priority. And so this would be referred to as 1-pentanol. Sometimes you see designations used where they use letters instead of numbers. And in this case, this one would be called N-pentanol for normal pentanol. And normal means simply that the hydroxyl group is located on a terminal carbon, on an end carbon. You might see for the first example where the hydroxyl is attached to the second carbon. That second carbon is what we call a secondary carbon because it's attached to two other carbons. And so that might be referred to as sec-butanol or S-butanol. So just another naming scheme that's used. Similar to when we talked about benzene rings, the difference between ortho, meta, and para. Those words are used to represent specific types of attachments, arrangements for the functional groups present. The last group here is based on the benzene parent chain, and it has a hydroxyl group substituted for one of the hydrogens, and this one has a special name. We don't call it benzenol. Its name is phenol, and it's not to be confused with phenyl, which was PHENYL, and that's the name that we use for a benzene ring when it acted as a substituent to another carbon chain. So it's important to know the difference between phenyl and phenol, and that phenol is the most basic benzene-based alcohol that we have.